We'll now take a look at computing with functions and arguments. In the process, what we'll do is delve a little bit deeper into R. So we've been using R, we've been using the pipe, we've been using some functions, but there are some aspects of it that we have not yet described or explained. So we'll get into those aspects now. Okay, so whenever you have a pipe, okay, the basic structure of a pipe statement is some input, which is usually a data frame. Okay, and then we use the pipe. So I'm using this to represent the pipe operator. And then we call some function. So for example, your data frame may be MPG, then you have the pipe, and your function might be point plot. And there are many other functions as we've already seen. So for example, there are many data wrangling functions as well. Okay, so you have the input data frame, you pass it on through a pipe to a function. Okay, so actually speaking, the function represents the operation that we want to perform on the input, and we have additional arguments that we can pass to the function to customize the function's behavior. And we'll see examples of that. Okay, so out of this function will come a result, and most often that result will also be a data frame, right? So the input is passed through a function. The input is a data frame. It's given to a function. The function produces also an output, which is a data frame. Okay, so here's an example. So we say SAT, that's the name of our data frame. Then we have the pipe operator, and we pass it through to the function head, which will display the initial some number of rows, 10 rows. Okay, so the input is SAT, a data frame, and the function is head. And we are not passing any additional arguments to the function. In other words, what we are saying is the default behavior of the function head is good enough for us. Okay, another example is SAT. Again, we are passing the SAT data frame through the pipe to the point plot function. But this time, we are passing an additional argument to the function. And that argument is our formula expression, expend tilde SAT. Okay, so that's the formula expression in which we are telling the point plot function what to put on the x-axis, what to put on the y-axis. Okay, now the point plot function requires this argument, otherwise it doesn't know what to plot. Whereas the head function doesn't require an argument by default. Okay, alternately, we could say SAT head 20. In other words, by default, the head function displays 10 rows, but you could say, well, display 20 rows for me. So this 20 is an optional argument that we can pass to customize how the head function behaves. Okay, so here's a function. We've got a point plot, and then we pass the first argument, which is the formula expression that is required for the point plot function. And then we say comma to separate the arguments. And then this time we are adding an optional argument, which is anot equals model, right? In other words, you could just do a point plot without an annotation, in which case you just say the formula expression, or you could have a point plot and then annotate it with a model or with some other things possibility. Okay, so we say then anot equals model. Okay, that's optional, but if you want an annotation, then you have to include this. Okay, so this anot is a named argument, right? Because we are saying anot is the name of the argument and we are passing the value model to that anot argument. Whereas the first argument, the formula expression, is an unnamed argument. We are not saying formula equals expend tilde SAT because that's the default. Okay, so that's an optional argument. We specify these through named arguments. Usually optional arguments are supplied through named arguments. Usually, not always. Okay, now again, since we are not trying to learn the language fully, don't stress about all of these things, optional, named, etc., etc. Most of the code that you're seeing is sort of template code. So you can just take the template and replace the template with whatever you need to. Okay, and you've been doing that already quite successfully, so there's really not much of a problem. Okay, now the interesting thing when you have pipes is that you can have compound pipe statement. Let's take an example here. Okay, so we know that the input is usually a data frame. We pipe it to the first function, and then that the result is a data frame which we can then pipe to another function, whose result is a data frame which we can then pipe to yet another function, and so on. Okay, so this is the advantage of using pipes, that you can perform one operation, take the result, perform another operation, and so on, which is very common when you're doing data analysis. So here's an example. Suppose there is a data frame called births 2022. Okay, now we want to create a data frame containing only those rows which correspond to babies who weigh more than 2,500 grams. Okay, so you could say this using the wrangling functions that we've already studied. You could say births 2022 pipe filter weight greater than 2,500. In other words, keep only those rows where the weight is greater than 2,500. That's a simple example. Okay, so here we suppose we want to create a summary showing how many babies were born at which places. Okay, so there is a column called place, and its values can be clinic, freestanding, home, etc., etc. So we want to find out within a data set that consists of 20,000 rows, how many rows have place as clinic, how many rows have place as freestanding, etc. Okay, so typically when you have a categorical attribute like place, and you want to find out how many rows correspond to each of its values, you can easily use the count function to do that. Okay, so we said births 2022 pipe count place. For every value of place, tell me how many rows there are in the data set. Very powerful, very useful function. Let's take another example. Suppose we want to use the births 2022 data frame and show only the weights of female babies. Okay, so we want only female babies, and we also want both the parents were older than 50. Okay, so several conditions. So we could say, and we want to display only the weight. Okay, show only the weights, nothing else. So first we say births 2022, and we can say filter, we want only female babies, so we say sex equals F, and both the parents are greater than 50, so we say F age, father's age greater than 50, mother's age greater than 50. Notice that we just separated all the conditions with commas. In a filter statement, filter function, when you separate the arguments with commas, which means you want all the arguments to be true. In order for something to be retained, all of these have to be true. So sex is female and father's age is greater than 50 and mother's age is greater than 50. Okay, and then the result of that is the filtered data frame. But this filtered data frame still contains all the columns, right? Because we just said filter, so it's still going to show all the columns, but only some of the rows corresponding to these values. So since we want only one of the columns, we then pipe it again and use the select function to list the only column that we want, select weight. Okay, so births 2022 is a data frame. After you filtered it, the result is a data frame, and we are passing the data frame directly to the select function. Okay, so notice how pipes make it very easy for us to just perform several operations in sequence. This is a very powerful feature, makes life very easy for us, and that's the reason we are adopting pipes so much in this course. Another example, from the births 2022, considering only babies heavier than 2000 grams, show the average weight of mothers of male and female babies separately. Okay, so lots of things going on here. First of all, we want to filter for babies weight greater than 2000, right? And then we want to take the average weight of mothers of male and female babies separately. Okay, average height actually. Okay, so we say births, filter weight greater than 2000. And then to find the average weight, we say summarize and then average mother's height, not weight, it should be height. Average mother's height equals mean of M height. Okay, and we also say na.rm equals true because there might be some missing values in that column mother's height. Okay, so if there are missing values, then the result would simply come out as null. Okay, because if any value is missing, you calculate the average, then the result is also considered to be a missing value. So in order to tell it, consider only the values which are not missing. You say na.rm equals true. So this will calculate the mean height, but we want it to calculate height separately for each sex. So we say dot by equals sex. Okay, so you can do a lot of complicated processing just by using pipes. Okay, now in this course, we're not going to get into a lot of this kind of data processing, but occasionally we'll do it and it's very useful and very powerful. Okay, so this is what the result is going to be of this particular operation. Let's take one more example. Graphically, examine if there is a relationship between the average age and of the parent and the weight of the child. Okay, so average age of the parents, which is mother's height, weight, and father's weight divided by 2. Add the 2 and divide. So first we add a new column called average parent age and calculate it as mother's age plus father's age divided by 2. Okay, so to the births 2022 data frame, we are adding a new column called average parent age and then plotting it. So we are piping it again off to the plot function and doing it just like we used to do before. Okay, so once again, you can see how piping makes things so easy for us. So we take the original data frame, pipe it to the mutate function, add a new column. So now you've got a data frame that has all the original columns plus the new column. That data frame, we are simply piping it off to the point plot and generating our plot. Okay, so all of these are good examples of how to use pipes. Okay, so this lecture has just been a quick overview of covering some of the gaps in our knowledge. Okay, but as far as this course is concerned, you can take the code that I'm giving you as a template and simply use that template for all your work, for all your data analysis in the course. Okay, very rarely will you have to actually sit down and write extra code which is outside of the template. So that completes our discussion of computing with functions and arguments.